Node.js application, just the basics. Also, basic building blocks of any Node.js application in terms of buffer, strings, pipes, etc., etc. Also, you'll see the most popular way to build a web server using Node.js, as well as a more deeper discussion in regards to NPM and in general packages with Node. And just a brief introduction to SQL and NoSQL databases, just kind of an overview. So what is Node.js? You might have heard that Node.js is same as JavaScript, but outside of the browser. And that's actually true. Basically, on this screen, you see that the basic and the most important building blocks of Node.js as a system outside of the browser. We have the same V8 engine. And at this point, you might have guessed that V8 engine is the thing that helps browsers understand our JavaScript code. We also have something in the middle, which is a LIBUV. We'll dive deeper into that. But that's basically what helps our code after it was parsed and compiled using V8 to kind of do the things outside of the browser file system, some network, etc., etc. So in place of basically the browser native systems that we have in Chrome, in Firefox, in any browser, we have V8. It's also the same purpose, but we need to understand that the part that understands JavaScript and the part that actually communicates with everything non-JavaScript are completely different, and they are V8 and LibUV. And finally, since we're already outside of browsers, we kind of get a freedom of not relying on clients, basically those who are using our website, to have everything installed, which is pre-installed in any browser nowadays. But we have the freedom to define what is available in the whole ecosystem. So NPM is basically an ecosystem or a package manager that allows us to not repeat ourselves. And we'll dive a bit deeper a bit later. So that was an overview of building blocks, or like underlying idea of Node.js. But what's inside Node.js in itself as a JavaScript environment is a way of running our JavaScript code outside of any browser. It also has an asynchronous event-driven runtime that runs our code, and it's designed specifically to handle lots of requests to our application without blocking anything. So that's almost the same as saying that we have synchronous code and asynchronous code, and asynchronous is a bit more convenient in terms of handling lots of things happening at the same time, whereas synchronous code is one thing at a time. So that was non-blocking almost, as everything in our computers. It's also a single-threaded thing, which is the same almost as we have with our browser extensions or browser itself. And there's no DOM. So going back to our discussion of LibUV, instead of LibUV in browsers, we have browser engine or rendering engine, and that's exactly where the DOM logic lives. But since we're outside of any browsers, we need something different, and that's where the LibUV comes into play. So instead of having to do DOM manipulations, we need to do network manipulations or file system manipulations, and that's actually what the LibUV is doing. A bit of history, some boring stuff, I know, but still. So there is a developer who who thought about having to run JavaScript not only in browser but outside the browser. He was not the first one who thought about this, but he was actually the first one who created something tangible and useful for not only himself. So it was in 2009. He supported only Linux at that time, but then after a couple of years of community effort, Ryan Dahl was able to actually shift JavaScript as a language, program language, further into the future of being on the same level as Python, maybe Java, or at that time Ruby. So not just a fancy language that gets our website looking more fancy, but is useless outside of browser environment, into something more a general purpose. So keep in mind that JavaScript, with the introduction of Node.js, has become more of a general purpose language than it was before Node.js. This is a map of the programming languages. I believe that's even more boring than any history of Node.js, but we gotta look at the JavaScript part and see that we're on top of the world, and that's because we write easy language on the front end, and we then go and use Node.js on the back end, and that makes everyone happy who knows JavaScript. So that's basically the summary of this picture. It is the one of the most popular things or platforms for backend development at the moment. The competing one is the C#.NET framework, and probably I don't see it present there, but all the Java-related stuff is also one of the competing ones. But Node.js, with its simplicity and purpose build, is taking over whole whole backend development at the moment. So all in all, to build something as scalable as Node.js, we would require some ecosystem to back it up. And that ecosystem, as I already mentioned, is the third building block of Node.js success, which is an NPM. So Node.js itself relies heavily on modules. It comes as any general purpose language with a standard library, sort of. But that standard library is divided into several modules, like math, network, file system, etc., for any purposes. Those libraries are called packages, and it's all either manually or they pre-installed, since they are kind of like a standard library. So nothing new to people who already using React and Webpack, because basically Webpack knows for it to work with files, etc., to build something or generate new files out of your own files, it actually uses Node.js under the hood. So since we're already using NPM, nothing new here. So you might be aware of what's happening. In regards to, since it's a developing technology, it has a kind of life cycle in terms of their release strategies, and it is basically when they release a current version, we know that there is an active version, or maybe kind of the next one, and we also know that before the active one there was a older version. So all in all, it is all about that the community of Node.js, when it releases a new version, it simultaneously maintains the older version, and it's already building a new one. So in terms of the installation, we can install the current stable version, and we also can install the latest, or in some other platforms it's called experimental, which is not stable, which is currently in development. So 3 versions: maintenance, current, and active, just in a different timelines. What is a server? I'm not going to dive deep into that at the moment, but still, JavaScript as a language that was born out of the need to do something in a browser, we need to kind of define what's its purpose outside of any browser. So whether we're running an actual web server or whether we're running some process that does the job when it's called. So in terms of the design, Ryan Dahl was facing several kind of goals, or facing issues, but aiming for some goals, and they are listed here. So it's a kind of package system, which is managing reusable pieces, dealing with file systems. So since we're not running in a browser, we need to do something that a browser does already, which is access to our file system, but with a greater extent. Browsers are not permitted to do most of the actions, and Node.js is actually is a solution. So we are installing it onto a real operating system. So it needs to know how to do what to do with files. And then it needs to have a way to connect to databases, basically making all kinds of requests using different network protocols, using internet. So it needs to have a network availability and what did they say? Connectivity. It needs to be able to accept requests and send response. It's as any server. So it needs to have a way to kind of like handle all the requests at the same time. So as we mentioned, we are building a lightweight version of asynchronous service, but it also need to have an ability at least do some work long term, maybe in a different process, but anyway, it needs to be able to run for a long time. And that's actually one of the first pictures of like Node.js ecosystem. I believe that's why it's so poor quality, but at least. On the left, we have that V8 engine. We use V8 engine and we send an input to V8 engine with our application. So basically with the code that we write, that V8 engine translates the JavaScript statements into some low-level statements, and then that's where the division in terms of browser versus node environment is located, somewhere here, or I should say maybe here. So you can think of it, of this part, Node.js bindings and LIBUV is a big box when we say web API, so browser system. So Ryan Dahl, he just cut the V8 part out of any browser and created his own set of libraries and some bindings for those libraries. Node.js bindings is here to translate those lower level commands that come out of V8 engine into sort of like C looking code that LIBUV is based on, because LIBUV was not actually developed for Node.js specifically. It was already present. We're just kind of reusing it, some kind of version of LIBUV, and has everything that is related to the event loop, as well as access to file system, access to network, etc., etc. But for this part, we can concern only with how the V8 is able to use event loop. The takeaway out of this picture, and maybe out of any browser-related JavaScript discussion, is that event loop is not part of V8 language. V8 is just an interpreter kind of, or partially compiler. But event loop is the thing that is provided by the environment where the V8 engine and our application is running. That means at some point we kind of diverged from the way that event loop works in browser into a new set of rules specific to running outside the browser, which is file system, network, process, etc., etc. So the key takeaway is understanding that this event loop is a different one. talking about V8, we already mentioned that this is just a thing that is able to understand our JavaScript language and converts into something that is a lower level, I should say. It's not like this, as far as I remember, but it's kind of like instructions that we send to further into the system. Might have been assembly language, but I'm not sure at this point. The thing is, it's just an interpreter or like the program that converts JavaScript into something else. It's open source. Different versions of V8, or I should say different versions of JavaScript engines is used in most of the browsers. So Chrome uses V8, Mozilla uses SpiderMonkey or something. I don't actually remember. But the thing is, this quote from Ryan Dahl is essential to understand how Node.js as a technology kind of relates to everything that we know of JavaScript so far. So Node.js is a set of bindings to the V8 JavaScript virtual machine, which could be translated that V8 needs something to call to do some work, and Node.js provide those means to call file system, network, etc., etc. LIBUV, again, it's a cross-platform asynchronous input-output library. It supports different kind of frameworks or libraries other than Node.js itself. So we think of it as a set of things that help us live outside of the browser, to have ability to call network and file system, and we have a particular version of LIBUV living inside Node.js. It has a different kind of same bindings for different languages. Julia is one of the competitors in terms of mathematics for Node.js servers. It has lots of different features. Key takeaways, I believe, file system events, so writing, reading, batching, ability to understand, create SPI and UDP connections, as well as child processes, so kind of spawning sort of like service workers or web workers in browser, but outside of it. Also, high resolution clock, which is interesting because not many people know that set timeout is not part of V8 in of itself. So when we talk about V8, we talk about only some basic features like understanding the syntax and math and promises, etc., etc. But clocking, which is the way of our code to kind of listen and be aware of time, is outside of V8. So that means we need to recreate it. And that's where the LIBUV package for high resolution clocking plays its role. So how do we install it? Pretty simple. I think simple Googling can work for anyone. One thing to mention for this particular slide, I think, is the difference between LTS and the current. Mentioned already, current is the stable version that was officially released, and LTS is the latest and greatest in terms of features, but it's not particularly stable. It is stable, but not to that extent as the current one. So it's hard to remember. Wait a second. So it has the latest features and recommended for most users, LTS. They have this strange thing, but I'm sure the website can be used to kind of understand. Basically, one difference from the other is that one would have a lesser version, less numbers in version the system. So just to be aware that we can use two different versions of Node.js at all times. Installation will be different for any other system. we can either install it as is globally. We can use something like NVM, which is Node Version Manager, that allows us to install several different versions, latest and maybe some old ones for legacy code, and kind of dynamically switch between them. So it's like a CLI tool for quickly swapping versions of Node.js when it is required. When we install Node.js, we also install npm utility, which is a set of CLI commands that allow us to perform the package management, like installing, deleting, running some scripts, etc., etc. So by default, as I mentioned already, Node as a platform, as an environment, has all the general purpose language features, which means that it's not only about interpreting your code and making it do some work, running it, but also it can be used as a REPL on-the-fly interpreter, which is read, eval, print, loop. Most of the languages, general purpose languages, have this ability, which is like kind of running code as is, typing commands in the interactive mode instead of kind of giving it some pre-written code and make it run and see the results. So REPL is a feature of any general purpose language. So a bit more about npm. Again, package manager. It has a central place somewhere on the internet. You don't actually need to worry about that. But as a global management system, which is located somewhere, but it also can be used as a proprietary registry, which means any big company, if it doesn't like the idea of having the packages installed from somewhere globally for security purposes, they can run their own npm sort of thing, registry, and keep the packages private and available only from the inside of the organization. So at the moment of creating this presentation, there were like 800,000 packages, so it's a lot. It has a high availability. I think it has a fault tolerance in terms of the terminology, which means it has almost 100% of uptime. It should have 100% of uptime because every time we do npm install, it hits the server, it downloads all the packages that are stored there, and then imagine how many people doing that at every single moment. So it needs to have that uptime. So think of npm registry as kind of a storage system somewhere in the world. It has a set of replications to be closer to users, where the packages in the form of npm modules or npm packages is stored, and we always pulling them from there. It looks like this. I'm sure you're well aware of that. We installed packages using npm install. Just to clarify, I think it's already obvious. When we do that, npm creates a special folder, Node modules, that huge chunks of files with that library that we require, but at the same time, it installs all the dependencies of that library, and it keeps track of these dependencies in a special file called package.lock. So in the package.json, we'll be seeing the package itself, and in Node modules, we'll see all the different files that were installed into our system. So package.json in general is a default version that Rindall proposed as a solution of kind of managing dependencies for any project. And package.json denotes all the scripts that could be run in this project or this application. Also lists all the dependencies that are required, for it to run in production, and dependencies that are not required. For example, development dependencies. It has different fields. They have all different purposes. They're not kind of hard-coded things that we all should be aware of, but if we're not publishing our package. So name, obviously, version is a major thing that we need to understand. There is a thing called semver specification, which is semantic versioning. It's kind of keeping track of versions of any packages, having different kinds of notations for 3 fields, major, minor, patch. So we're not going to dive deep into that, but just be aware that npm follows the semver. So in the registry, there will be packages that have specific versions with a specific kind of convention of how they kind of note it. So yeah, there are some discussions about how the versioning works. So initial release, bug fixes, increase or increment the patch version, major features, non-breaking features will increment the minor version, minor part, and the major changes that break backward compatibility, they increase the major part of semver. That's all it is. So it kind of like when you look at the package itself, you see that if this number changes, you know that there won't be any breaking changes, and there won't be any new features. So kind of like having versions describe themselves. So there is a process of starting a new package. If you're interested in it, and we'll walk you through the main steps, which is when you run npm init, it will ask you for the version of that package. Most of the time will be the first version, some description, maybe name, etc. Keywords, author, license. Some of these keys are important. They denote kind of like the entry point into your application, but they could be changed at a later stage. So if you run npm init and forget to do some important things, you can always change it in the package.json itself. It assumes default kind of versions or default values if they're omitted. And these values are email, name, maybe license, and as with Git, that uses your credentials, uses your name, etc., etc. npm also has its own npm rc or npm config, something like that, that keeps track of those changes. So it will leave somewhere alongside the Git related configs globally in your machine. So we can change that using npm config list, but that's actually not the focus of today's lecture. The most important thing to know when starting out with Node.js and kind of be more aware of how packages work is different between the dependencies and dev dependencies. So in general, dependencies are kind of the minimal amount of external things to your application, dependencies, packages, etc., that need to be installed in order for your application to correctly run in your environment. So typically, when you've created your application, you want to run it, you don't want to have Webpack available at runtime, or testing framework available at runtime, or ESLint. Those dependencies should live in dev dependencies, since semantically, dev dependencies are used during development, obviously, and they won't be needed when the development is done already. So this is an assumption that Ryan Dahl made and the community made. to make sure that we are not building something huge that is so heavy that it gets 20 minutes and more of build time just to pack everything and ship it somewhere to those machines that will run our server. So that was the assumption that we need to build and test and lint and do all like CI/CD stuff before we publish or like deploy our application. So there is a dependencies again, which with minimal amount of packages needed to successfully run dev dependencies, packages that are needed in order to build your application. There are also peer dependencies and other types of dependencies. They will differ with this prefix. They serve a different purpose, but for now, most of us will use dependencies in the dev dependencies. That's that. We specify which dependency we're installing when we use --safe, or just omitting this part. It will install it into, I believe, dev dependencies. So this flag kind of chooses the dependency that we want to install. So if we specify --safe dev and hit install, we'll be installing it to dev dependency. If we want to have a dependency that's needed for our application, this usually is the notation to do that, or make sure to do that. When we install different kind of types of dependencies, we, as I said, create a list of external dependencies. So Lodash, Webpack, they're not kind of dependent-less dependencies. They sort of rely on other things that were built before their time, and those things rely on the things that were built before them, etc., etc. So package lock will have all those dependencies listed and the relation between them listed. So whenever you run npm list to see what kind of dependencies and included in any of the packages, you receive that list, and that list denotes with all the package-lock, and we'll talk about that in a bit. So yeah, we've got scripts in our package.json, and that's the way to kind of build or document, I should say, a way of running our applications. So instead of the development team keeping that knowledge to themselves and being the only one who can run these dependencies or this application, we kind of document the scripts, reducing the development time, and also allowing anyone who's new to the system, new to the code base, to see what they can do with application, or what should they do to build it, run as in a dev mode, in watch mode, etc., etc. That's the way we do, and it's just a set of key value pairs that we use with word run. So npm run and then a name of the key, and the value would be inside substituted directly. There is a way to kind of force npm to do something before or after installation. There's kind of there is a notation with pre and post prefixes. It is useful to run some tests, maybe, or some configuration management sometimes. Just be aware of that it exists. So whenever I run npm install, it will do something after I install, and this is what bow install means as a value. So types of modules. A number of modules that could be written in Node, JavaScript, and JSON. Just be aware of it's not an exhaustive list of modules. It could be built with Node.js, just a typical one. One thing to mention is that there is a standard modules inside of Node.js with the usage of V8 or maybe LIBUV. You have the ability to kind of access those Node.js bindings. And as it turns out, most of the higher level language, they use some sort of C or C++ under the hood, and Node.js is not an exception. So we kind of able to, apart from writing Node.js code or JavaScript code, as it turns out, we can write C code or C++ code and tell our Node.js platform to use the code that we write in a different language for very, very specific things. Just kind of to, it was a design decision by Node.js community to be able to swap some of the elements that come from standard modules as a way of customizing it. So think of it as a just a design, software design pattern, kind of open, closed principle from Solid. JS modules, they look exactly the same as they look in browser, but they do have some differences in terms of some syntax. Since we are not in the browser, our JavaScript files by default in browsers, they are global. That means we need to separately include them into any HTML that we want to use our JavaScript code. Since we're outside of browsers, we can either do the same thing, running some CLI commands and run all the scripts and manage their kind of the queue, or as Node.js community thought about, we can rely on Node.js before it launches the code or the application, the actual application. It pre-builds it, and that allows us to kind of make that building step to do something useful for us. And it was decided to have a module system. So we know from front-end development that there is a module pattern from a basic set of JavaScript design patterns, and require in Node.js followed the same thing. It has evolved that module pattern into something more useful but different from what we have in front end, just because we have this build step before running the code. So we use something called common.js, and exporting from any file is done with the keyword exports or module.exports, and then the name of the thing that you want to export. And importing is done the same way. So if I'm doing a named export here, or I should say kind of named here, but unknown here, I should import the whole thing, so the whole package, and then use it as if I imported only the users. So it's kind of like a syntax thing, so you need to just remember it. It's sort of similar to import export that we have in Webpack and React and Babel. It was just an old version, or the way that Node.js used to be, using common.js module system. JSON is also supported. We can import JSON into our code, into our application, as a similar notation that we're all used to. We just require this config, and Node.js, in contrast to our front-end or Webpack-based systems, it is able to understand JSON on the fly and use it as if it just made a call to the backend. So that's that. So it's a similar one to simple JavaScript files. This is how we do the directory. So since we're in the file system, we kind of have the same thing as outside of Node.js or in the Bash environment in terms of how we access the environment or the file system itself. So just skipping the same notation that we're used to in CLI, we are accessing all the files from there. So as it turns out, this is a user and it imports a dictionary.json. The extension is not required because it's just passes the name, and it is imported as a variable. Inside there is a JSON, so some kind of transformation from JSON to JavaScript object happens on the background, and then we just directly use it. That's kind of a cool way to have. So, as I already mentioned, there is a number of module systems based on that module pattern that we have in design patterns. And the first one to know is the common JS module system. It is the one that uses require statements in module.export. Then at some point, Node.js started to support ES modules, which is, or system.js. So it's a different flavor of doing the same thing. So importing different files when we need them. Just for you to know that there is a way to do imports of modules in various different ways, but the most common ones are native to Node CommonJS and adopted from frontend and Webpack and Babel practice ES6 modules, basically. So import, export, the one that we used to do from Webpack perspective. So if we talking about this module.export, by the notation you might assume that this is some kind of object, and inside that object we have a number of useful things. So exports is just a field with a value of an object. So when we do exports dot and then specify some name, it's just a simple JavaScript thing. So, but it has also some different available things. They're mostly not used in a day-to-day development, but it's a good thing to be aware that the module system keeps track of all the dependencies, denoting their circle or not, using the children and specifying all the different modules it has as dependencies. So just be aware that module is an actual object global to our environment. So module as app and component, that's what we already discussed. Same here, exports. There is a way that we kind of has a convention of using module.exports apart from just running directly exports. That was just for convenience, but it turns out it has some problems with circular dependencies, so it's better to use modules.export all the time, or just go with the ES6 module system all in all. That was quite a lot of information, but I think it was a good start for you to kind of get an idea what it does, Node.js, as a platform, as an environment, where it sits in the whole JavaScript community and ecosystem. There are links for further reading. I'm sure that you, or whether you could just Google them, or like Node.js official website, nodejs.org, or the GitHub to see all the versions and work in progress of lots of different people doing for the Node.js ecosystem. And that's because we have most of the companies nowadays using some sort of Node.js on their servers. Some go with fully Node.js, allowing them or their developers to be kind of full stack quite easily, doing front end and back end in the same language and the same syntax. Some companies use it for specific purposes that Node.js was built for. It's not just a server. It's the server for specific things. So remember that, single threaded, etc., etc. But also the big ones that we use as developers, not just as consumers like here, but as developers, we use lots of different things. For example, clouds or applications that are based on those clouds, and those clouds basically support many different languages, and Node.js is becoming the most popular solution. That was not supported at the beginning, but when it became supported, it was just this skyrocket progression of Node.js usage in the cloud. So Node.js as a platform is supported by Microsoft, Amazon, and Google, and I think the Alibaba cloud also supports that. Again, useful links to the mentoring program, to some websites, and a list of JavaScript engines that I mentioned in this lecture. Yeah, questions, maybe ideas, so feel free to ask them. All right, so all clear today. That's cool. That was just an introduction. There is lots more information coming. So right before you thought that React was the complex way of doing JavaScript, there is a JavaScript on the server, and with all the different frameworks, flavors, etc., it's just a mess. But you need to get the basics to kind of be okay puddling in that mess. So hopefully we'll get everything sorted by the end of our set of lectures, at least the basics. So you kind of get the idea whether you want to go fully in the back end or full stack, or you like the comfort of front-end development. Speculations always. Thank you very much for your attention. The link to the recording will be available here, I think, and see you on the next lecture. Bye.